Hello, my name is Grace Peterson, and today I will be talking about auroras. Auroras are breathtaking moving waves of light caused by a certain cosmic activity. Although auroras have existed since the dawn of our planet, and even dinosaurs could have borne witness to them, it wasn't until 1619 that Galileo gave the northern lights their name, Aurora Borealis, based off of Aurora, the Roman goddess of dawn, and Boreas, the Greek god of the north wind. Although we tend to talk about the northern lights more, there is also a southern counterpart named Aurora Australis. The best time to view the northern lights is September through April on a clear night in places like Norway, Iceland, and Greenland. But how does this occur? Well, when free protons and electrons move too fast to be contained by the sun's gravity, they form plasma that travels away from the sun as solar wind. The Earth's magnetosphere, which is formed by the Earth's magnetic currents, works as a shield and blocks the solar wind, protecting us from harmful radiation. Under certain circumstances, the magnetosphere isn't enough to just redirect the solar winds, such as in the case of a coronal mass ejection. A coronal mass ejection happens when the sun shoots a massive expulsion of plasma, enough to overpower the magnetosphere. The magnetic field then deflects some particles from the massive onslaught of solar winds towards the auroral ovals at the poles. At this point, the protons and electrons interact with different atoms in the atmosphere. When they come into contact, they emit photons or bursts of energy in the form of light. Every atom or molecule absorbs and radiates its own unique blend of colors, sort of like how every human has a unique set of fingerprints, or how no two snowflakes are exactly the same. The colors of the aurora depend on the wavelength of the atom's photon. Excited oxygen atoms will produce green and red colors. Excited nitrogen atoms yield blue and deep red hues. And if ions strike hydrogen and helium atoms, purple auroras can even be produced, although sadly this part of the electromagnetic spectrum is rarely viewable with human eyes. Scientists are starting to find cases of auroras on other planets too. Auroras are different on other planets, which makes sense since the magnetic fields are so different. This is an artist's depiction of a discrete aurora on Mars, although we don't know for sure what it would look like with human eyes. It's exciting to think that maybe someday we could have a picture of what auroras look like on other planets. That's all I have for today, so thank you for joining me, and maybe someday if you're lucky you can see an aurora for yourself.